Okay, today we're going to talk about the high frequency oscillator ventilator, or more commonly known the oscillator. Okay, now this mode of ventilation is high frequency, so it can breathe anywhere up to 600 to 900 breaths per minute. It's more commonly used for patients, infants or newborns, and adults as well, where their lungs are very non-compliant and it's hard to ventilate them with conventional ventilation such as volume control or pressure control. Okay? Specifically for newborns, IRDS type 1, where we have newborns who are premature and their alveoli are basically non-compliant because of surfactant deficiency, or meconium aspiration syndrome, where the meconium that is aspirated, usually by post-term babies, have destroyed or damaged their alveoli, causing a lot of atelectasis, making it very hard for us to ventilate the alveoli, and they're very non-compliant. Okay, so the first thing we're going to do, as you do with all ventilators, is connect your gas source, which is your air and oxygen hoses that you will connect to your gas source, which is usually on the walls as a quick connect, or it could be actual 8 cylinders itself. We have a gas compressor, so I've already hooked those up and those are on. And the next thing, to power the ventilator, like most ventilators, we will power it on by connecting the cord to the power outlet to start up the ventilator. Okay, before actually connecting our circuit to the oscillator, let's talk about the components that we will connect. First off, this is our rigid circuit that will connect to the oscillator and will connect to our patient. This is the diaphragm, and this is a cylinder canister that basically connects the condensation from the ventilation. Here are our flexible tubings that connect to the oscillator onto the humidifier, and from the humidifier to the rigid circuit. Okay, and here of course is our cascade top for our heated humidifier. And again, these are just our pressure lines and our dump lines and our limit lines as well. Now we're going to connect our circuit. The first thing we want to connect is the diaphragm, and we want to make sure we put the diaphragm right in front of the drum. Okay, so here's the drum right here and the diaphragm, and there are 4 locks here, so I basically want to make sure that this is all locked in so that it doesn't come out. And then our cylinder here that basically catches the condensation, I'm going to put right here. The next thing I want to connect is our rigid circuit here, and basically this part here, the big opening, will connect to the diaphragm, and it's kind of hard to put in place, so you kind of just have to work its way in. Okay, after that's in, this is the airway pressure line, and the connections for the pressure lines are basically color-coded, so it's very hard to make a mistake here. Okay, you just connect this and that part is now ready to go. Next thing is just to connect all the lines. Again, they're color-coded, so it's very hard to make a mistake here. And they also have certain lengths where there's only one way for them to be connected, so again, very hard to make a mistake here. Okay, so we're just going to connect these. So the blue's on this side and the green is on to the right side. Okay, so there you have it. Okay, next I want to connect my circuit to the humidifier so that the breaths that we are going to deliver is going to be humidified. Okay, so first thing is I'm going to connect the humidifier to the circuit, to our rigid circuit, and that is a little connection underneath the rigid circuit itself, connected to the humidifier, and the humidifier will connect to the gas source of the oscillator in the back. Okay, it's the only connection back here, so again, very hard to make a mistake here as well. First thing before we power the oscillator on, one thing we want to make sure is you have the stopper at the end of the rigid circuit here. Okay, and next we're going to turn on the power button right here. Okay, and as you can see, all the lights turns on, and we are going to basically adjust all these pressures and all the limits before we can get this oscillator going. The first thing we want to do is we want to adjust our bias flow right here at about 20, and I've already preset that. The next thing I want to do is turn my inspiratory time to 33%, which I have here, and I'll set my frequency to 15, okay, or our hertz. Okay, so that's at 15. Okay, And now that everything is set, one last thing I need to set is actually the mean airway pressure, and I'm going to increase that all the way to max for right now, okay? Now, to turn this oscillator on, I first have to build up power or the pressure within the system. So I'm going to do that by pressing this reset power fail. Okay, and as you can see, the mean airway pressure is increasing. And let me turn off that alarm. As it increases, you wait for maybe about 5 seconds and then you can press the start button. And there you are. Okay, the oscillator is starting. And what I want to do now is connect my mannequin so you could see the oscillation of the high frequency oscillatory ventilator. So as you can see, here we have our oscillator now that is actually on and it's connected to our mannequin here. But right now it's very hard to see the oscillation on the mannequin because the skin on the mannequin is very thick, so it's very hard. So in a little while, what I'd like to do is connect my test lung on so you could actually see exactly what the oscillator is doing to a lung. So I put on my test lung here so you can see exact vibrations of what this oscillator is doing. I'm going to turn down the hertz to be about 12 hertz. Each hertz is about 60 breaths per hertz. Okay, so at 12 hertz, this is going to give us about 900 breaths, okay, or 900 oscillations. Okay, and as you can see here, this is what we're going to be doing to our newborn's hearts or our adult patients with ARDS. So here's an up-close picture of what our oscillator looks like, or the face of it at least, okay? This here is our frequency or our hertz. Here's our amplitude, and the amplitude and the hertz are basically your management for ventilation. So if CO2 starts to raise, we're going to look at our frequency and our amplitude, and we're going to adjust those up to try to blow up CO2. Alright, the next thing I want to look at is our mean airway pressure, and our control for our mean airway pressure is right here. The mean airway pressure works like PEEP. So for oxygenation difficulties, what we're going to do is increase or decrease our mean airway pressure to improve oxygenation, along with FiO2. Over on this side of the panel is our mean airway pressure limit, okay? Our mean airway pressure right now is at 23. What I like to do is I like to set the mean airway pressure about 2 above and 2 below. So this is the max airway pressure. Right now we're at 23. So I want to set this at about 25.5 or 26. So I will manually just turn this down. There's 25. And I'll turn it to 26. Now the low, I'll set 2 to 3 below. So I'll set this at about 20. And there you are. So our mean airway pressure is at 23, and our max mean airway pressure is set at 26, and this low mean airway pressure limit or alarm is set at 20.